you go. Okay, on this slide then, on the left-hand side, we've got in green our LTE network. It's labeled a private network. We saw that term a little earlier. Mission critical networks are going to be private networks. We don't want the general public using a mission critical network. But on the right-hand side, we're looking at the TETRA system. So, we're focusing on interworking between LTE and TETRA. Now, within the TETRA network, the core network is referred to as the SWIMI, the switching and management infrastructure. And the SWIMI is largely proprietary. One of the things about TETRA is only the interfaces into and out of the system that are actually defined by the TETRA standards, the ETSI standards. So the SWIMI is a proprietary system. However, ETSI have defined a way of actually interconnecting different TETRA networks together using a system called the ISI, the Inter-System Interconnection. And it was designed to connect TETRA networks together across international borders. In the early days of the standards, that ISI was based upon 2 megabit transmission lines. It was a TDM system. But these days it's based upon IP in line with the rest of the telecommunications world. So it would make sense perhaps for ETSI to define the interworking function. So I've drawn the IWF box inside the TETRA system. So it could be based upon the ISI as mentioned, and of course using the 3GPP defined interfaces, IWF1, 2 and 3 as shown in the diagram. Now, ETSI have partway developed some standards with regard to interworking. The document to have a look at is the technical specification 100.392-19 as shown in the slide. There's 2 parts to that particular document. Part 2 deals with speech transport, and that is now complete. But the first part of the document, which deals with protocols, it is not yet finished. So this is clearly going to be a work in progress. Overall, the idea is that the TETRA terminal, if he wishes to communicate to a mission critical user, will actually think he's just talking to yet another TETRA user. And likewise, a mission critical user should be able to communicate with the TETRA terminal as if it was just simply another mission critical user. But we have a couple of issues. First of all, the speech codec used in TETRA is not the same as the one used in LTE networks. TETRA uses the ACALP, the algebraic code excited linear predictive codec, whereas an LTE network is likely to be using an adaptive multi-rate codec or possibly an EVS codec. So the interworking function will need some means of transcoding between those 2 speech formats.